I'm going to go over a couple problems from section 10.4 on inverse functions. Now, inverse functions, you know from college algebra, first of all, they have to be functions, but they also have to be one-to-one. One-to-one you check with the horizontal line test. Let me just see if I can draw. If you look at a sine function, one period here, one period there. A sine function is actually not one-to-one. It does not satisfy the horizontal line test. If I draw a horizontal line, my horizontal line intersects in two places, so the sine is not one-to-one. That's why we have to restrict the domain. And for example, especially for the sine function, we're only looking to find the angles between negative pi over 2 and positive pi over 2. So that's how we get away from not being one-to-one. We're just restricting the domain, just like we did in college algebra with the parabola, which is also not one-to-one, but when we only looked at a piece, so restricting our domain, we can find an inverse now. So for the inverse sine function, the range goes from negative pi to positive pi over 2. I meant negative pi over 2 to positive pi over 2. For the inverse cosine function, the range is from 0 to pi, and for the inverse tangent function, again, it would be from negative pi over 2 to positive pi over 2. So one of the problems in 10.4 is finding the inverse tangent of negative square root of 3. Now again, what you're trying to find now, and I already rewrote it, is you're trying to find the angle for which the tangent is equal to the negative square root of 3. So again, we can only look for angles that are within positive pi over 2 or negative pi over 2. So if we go counterclockwise, we have our positive angle. If we go clockwise down here, we have our negative angle. So for which angle is the tangent negative pi over 3? If we have to look in quadrant 4. If we're looking at the entire 2 pi circle, that would be 5 pi over 3. But since 5 pi over 3 is not within pi over 2 and negative pi over 2, we now have to change and look strictly at the negative angle. So therefore, theta would be negative pi over 3. So a common mistake here that students make is that they write the 5 pi over 3, but that would be wrong, since your angle, if I say it in degrees, can only be between 90 and negative 90 degrees. So we have to use the equivalent negative angle. So here's another problem. Find the exact value in radians of the expression, the inverse tangent of square root of 3 over 3. Again, if you translate it, it means for which angle is the tangent. So you're looking for theta, for which angle is the tangent for square root of 3 over 3. Now this time we have the positive relationship, so we are in quadrant 1, and the angle in quadrant 1 would be pi over 6. And here's another one. For example, the inverse cosine of negative square root of 3 over 2. Now for the inverse cosine, our range is between 0 and pi. So we're only looking for angles in quadrant 1 and in quadrant 2. So the angle would be, in this case, in quadrant 2, like so. So in quadrant 2, the angle that gives us a cosine of negative square root of 3 over 2 would be 5 pi over 6. Okay, how about one more? The inverse sine of square root of 2 over 2. Now, the range for inverse sine is just like the tangent, quadrant 1 and quadrant 4, from negative pi over 2 to positive pi over 2. Since our relationship is positive, we are in quadrant 1, and square root of 2 over 2, our reference angle here would be pi over 4, 45 degrees, and that is between negative 90 and positive 90 degrees, and we are in quadrant 1, so this should be pi over 4. Here's another problem. This time give the degree measure of the angle, and you're looking for the inverse sine of negative 1, which again means for which sine of theta is, do we get negative 1? And that would be in quadrant 4. Negative 1, or actually not in a quadrant, it would be on the y-axis. We have the point 0, negative 1 right here. So the angle in this case would be negative 90 degrees, or negative pi over 2 if it were to be in radians. Then you have a couple problems where you need to use your calculator. And then you have some problems, for example, let me change the page here, where you have given give the exact real number value of the following expression without using the calculator. The tangent of the arc cosine of 16 over 20, something similar like that. Now, basically, this part here is the relationship that forms the angle theta. So, always good to draw a little sketch. The inverse cosine 16 over 20 would be in quadrant 1. Make your right triangle. So the angle that is formed here is cosine is adjacent 16 over 20. So this is the angle relationship that is being formed by the inverse cosine of 16 over 20. Now, based on that, you have to find the tangent of this triangle, which again means that you need to find the missing side, the opposite side, because tangent is opposite over adjacent. So the opposite side, let's call it A, we're going to find by using the Pythagorean theorem. So that would be 220 squared minus 16 squared. So 20 squared is 400 minus 256, and that is equal to 144. And of course, this would be all squared. Now to take the square, to find A, we take the square root of 144, which is 12. So the opposite side here is 12. So that means we find our tangent relationship, which is opposite 12 over adjacent 16. That can be reduced by 4, and we get 3 over 4. So again, make yourself a little sketch. The inverse cosine in this case always forms the angle relationship, and then you just find the tangent. Let me do one more problem here. Write the expression as an algebraic, meaning non-trigonometric expression in u, and u is greater than 0, so positive. We're looking here for the cosecant of the inverse tangent of u. Again, this relationship will form our angle that we need. So u is positive. I make a little sketch. Now the tangent is opposite, so this side is opposite u over 1. You can just write inverse tangent of u, and this, if we need it as a fraction, of course, is over 1. So we need to find the cosecant, which is the reciprocal of the sine function. For that, we need to find the hypotenuse. So the hypotenuse, we're using the Pythagorean identity theorem, u squared plus 1 squared equals the hypotenuse squared, that is. So if we want to find the hypotenuse, we take the square root. So the hypotenuse is the square root of u squared plus 1, and that cannot be simplified any further. So we write on here u squared plus 1. And now to find the cosecant is hypotenuse over the opposite, the reciprocal of the sine. So the hypotenuse in this case is square root of u squared plus 1 over the opposite side, which in this case is u. And that does not need to be simplified any further. So these are some problems from section 10.4.